And it represents to some of us evidence that in fact the climate system seems to be accelerating. Now I'll talk a little bit about more at that in a later slide. So we've got evidence that the climate is changing. Is it us or is it natural variability? And the answer is now very clear. It's us. Now, here's the results of some model calculations. We've got increasingly better climate models that can reproduce today's climate, for example. And we know what the atmospheric conditions have been, what the forcing of the climate's been over the last at least 100, 150 years, without any question. Forcing due to volcanoes, due to changes in the sun's output, due to the greenhouse gas concentrations. If we now take only the natural forcing due to volcanoes or changes in the sun's radiation and put that into the models, we can make some projections about what the climate would be. And that's what's done on this lower graph. The black curve is actually again a reproduction of the observed temperature increases, and the blue is what you get from the climate models. And so quite clearly, although at the beginning of the century the agreement's not too bad, it gets progressively worse as you get to the present day. If we now, in addition, take the forcing due to greenhouse gases and put that also in the model, then we get the red curve. And you can see that the agreement is really rather remarkable. The fact that there's quite broad here is to imply that it's actually not based on one model and not one model run, but about 20 odd models, some of them run many times. You cannot reproduce the observations unless you invoke the differences and the changes in the concentrations of greenhouse gases in the atmosphere. And so as the IPCC in its fourth assessment concluded, and I quote, "Most of the observed increase in global average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations." Very likely is in italics there. Those are well-calibrated statements to the IPCC. Very likely means at least 90% certainty. And any of you who have done science know that if you've got a result and you can say it's 90% certain, you're doing very well. It doesn't get much better than that. Now, I'm talking about globally. Climate change is accentuated in the Arctic. For several centuries, decades rather, the surface air temperature in the Arctic has warmed at approximately twice the global average. And of course, this is even greater in spring and in winter. The trends have been evident for some time, but there's now increasing evidence that we perhaps are getting to what some people refer to as a tipping point, where the changes are of a different nature. Let me give you an example. And it's what this slide's about. It's about the Greenland Ice Sheet. In the IPCC third assessment report, which was completed in 2001, it was concluded that the Greenland Ice Sheet is expected to decline if the local warming is of the order of 2.7 degrees Celsius. And such a warming is possible with a doubling of pre-industrial era atmospheric concentrations of CO2. We're not far from that. As I've said, the CO2 concentration at the moment is 280. Twice that is twice the pre-industrial is twice 280, which is about 550. So and if you include not just carbon dioxide, but the other greenhouse gases like methane and nitrous oxide, then the present equivalent CO2 concentration is more than 380. It's close to 450. So we're not that far away from this possibility of getting a local warming of 2.7 degrees Celsius. And with that, the deglaciation is likely to be irreversible. We now know that that was a significant underestimation. Although there's been a thickening in the center of Greenland, due to enhanced precipitation. Along the coasts, the glaciers are moving very fast, much faster than we anticipated. So fast that we've actually had to recalibrate our understanding of glacier physics. And what happens very simply is that because the surface is warming, you get a lot of water. This is on top of the ice sheet. And that water flows through crevasses. And that water actually goes to the bottom of the ice sheet and stays as liquid water, which itself is amazing. And through hydrostatic pressure, lifts slightly the glacier and lubricates the bottom with the water. So you can imagine what happens when you have those circumstances. The glaciers can move much faster, and they do. And the Jakobshavn Glacier over here somewhere is moving now at a rate that you can actually see with your own eyes as you stand there. And to my mind, this just underlines the importance of the urgency of tackling climate change. A little bit at the Arctic sea ice. We've already seen over the period that we've had comprehensive satellite measurements that the Arctic sea ice has been declining by about 2.7% per decade since about 1978, with a much larger decrease in the summer of about 7.4% per decade. And projections from climate models, which are shown here, suggest that by the middle of the decade, there could be no significant, or at least not towards the end of the decade rather, no significant ice at all. And this is clearly going to have consequences for navigation in the Arctic. It will first happen along the Russian coast, what is called the Northern Sea Route, with the number of shipping days increasing from what is now about 20 a year to about 100 a year by the middle of the century. It's going to be possible to go across the centre of the Arctic Ocean by the middle of the century, and later through the Northwest Passage. But of course, we may be wrong. We may be again conservative in that. Many of you know, I'm sure, of the recent observations of the sea ice in the Arctic that is now lower than it's been ever recorded. And in fact, in some parts of the Northwest Passage where the icebreaker research ship Amundsen is now, they are not seeing any multi-year ice at all. So what worries me, as I've hinted, is that in fact the climate system may actually be accelerating. And this shows some diagrams from the IPCC's fourth assessment report. The IPCC, in its plenary session, when it adopted the summary for policymakers, shied away from making this comment. Scientists are always somewhat conservative. And in this case, they may be more conservative than normal. But if you look deep into their report, you can see evidence that in fact suggests the climate is accelerating. So this is sea surface temperature, the different records, and it seems to be increasing. This is sea level, and sea level rise over the last 15 years. It's almost twice as large as it has been over the previous 50 years. This is Arctic sea ice, and you can see what happens. In this and everywhere else, but most dramatically here, if you take the observations over the last, 35, 40 years, you cannot draw a straight line through those points. It's non-linear, and this is snow cover extent.